guys, welcome to today's class, and in this video we are going to talk about isotopy and isotopes on board here. So now, what is an isotopy? Isotopy is a phenomenon whereby atoms of the same element have the same atomic number or proton number but different mass number. Now consider an element X. X is having isotope of what? This guy is having what? 3 watt isotope. So this isotope is having what? They're having the same atomic number or what? Proton number. But if you should look at what the mass number here, this one here is having what? 17. This one here is having what? 18. So here is having what? 19. So the phenomenon whereby atoms of the same element have the same atomic number but different mass number is called what? Isotopy. Then isotope is what? Is the individual what? Atoms itself, themselves. The individual what? Atom themselves, right? So this one here is what? Isotope of what? X. Isotope of what? X. Isotope of X. Do you get that? So what you want to actually understand is what? How to calculate the relative atomic mass of an element with the what? Various what? Isotope. You get? So now to calculate the relative atomic mass of what? Of an element with various isotope. Now we have different methods to use, but the simplest method I've seen so far is what? Is formula what? Method which is what? This guy here. MR means what? Relative mass of what? Of the element what? Various isotope equals to what? A1 times P1 plus A2 times P2 plus A3 times what? P3, only what? P1 plus P2 plus P3. Now, where is A1? You may ask. A1 is what? Is the atomic mass unit of what? Of the first isotope, or what? The mass number of what? Of the first isotope. Do you get that? So if you look at this element here, if you look at this atom here, now the atomic mass of the first isotope here is what? Is 17. Do you get that? 8 is what? Is the atomic mass unit of the second isotope, which is 18. Then 8 is what? Is the atomic mass unit of the third isotope, which is what? 19. You get? So P1, P2, P3 is called what? The percentage abundance. Each of these isotopes have their what? Percentage abundance. They are found in the what? Element X. You get? Now when you sum their percentage together, their relative abundance together, you're going to give what? 100. That's why we have P1 plus P2 plus 3 equals to what? 100 what percent. The summation of all the relative abundance or the percentage abundance equals to what? 100 what percent. So now when solving a question and you are being asked to calculate what? The relative atomic mass of an element what? Various isotope. Now you'll be given two things. First, we give what? The relative atomic mass of what? Of the various isotope. 2, you will give what? The percentage abundance of what? Of the various what? Isotope. So once you have those values, what happens is to what? Substitute them into what? This what? Formula, and what? Calculate your answer. So I'm going to show you one question. Then I want to link some question at the description where you are going to see some similar question and would solve for yourself, right? So now let's look at the first. So now look at what the first question about. 3 isotopes of neon are known. Use the following data to calculate the chemical atomic weight of what? Of neon. Now look at the table given to us here. Now here we have neon 20, neon 21, and what? Neon 22. Now here are their what? Individual what? Atomic mass units. Here are their what? Relative what? Abundances, right? So you have this here. So remember, you can use the what? That small formula I gave to you to do this calculation here. Here we have what? M what? R equals to what? A1 times P1 plus what? A2 times P2 plus what? A3 times P what? 3 over what? P1 plus P2 plus P3, right? Remember that A1 is what? Is what? Atomic mass unit of the first isotope. Then P1 is what? The percentage abundance of the what? Various isotope. So what you want to do now is what? Substitute your variable value into that what? Formula here, right? So here we have what? MR equals to what? Which what? Relative atomic mass, right? Now you also say that what? Chemical atomic what? Weight of neon. They are the same thing. So here we have A1 is what? 90.112 times P1 is what? 90.12 plus, here we have what? A2 is what? Is this guy here? I think my thing was 7 isotope, which is what? 20 the what? 994 times 0.25 0.257 plus A2 is what? 21.991 times 9.62 right, over, so we sum all it together, sum all their percentage abundance together. Here we have 90.12 plus 0.257 plus 9.6.2. You get? So now what you want to do here is that you must use your calculator. It's preferable to use your calculator here. You can punch all your values into your calculator like this and get your answer. You get? Remember, when you sum all this one here, it must give you 100. You get? So what you want to do is to open your bracket. Bracket open. Now your calculator here, bracket open 90.112 times this plus. So you are going to sum it together. So now when you finish punching your calculator here, bracket open, divide by 100. Now when you sum all this one here, it's going to give you 100. So your final answer is going to be what? M R equals to what? 19.3 19.3 So that is what answer. So the value now the is going to be what? Which what? Atomic mass units. So with the help of this your calculator, you can punch your values there and get your answer at once. You get? So these are to solve question. So now let's look at another question. So now let's look at second question here. They say that an element X which was relative atomic mass 16.2 contains 2 isotopes. Isotope 16 with abundance of 90 and isotope M with relative abundance of 10. What is the value of M, right? So now when you look at this question here, now they gave the relative atomic mass of the element X, which was 16. So in saying that, now this isotope here contains only two isotopes. So here we have M R equals to A1 times P1 plus A2 times P2 over P1 plus P2. Now, if you see in the question here, that gives us our relative atomic mass of the elements. So my relative atomic mass of the elements R here, MR is 16.2, 16.2, right? And the first isotope. Now remember, this one here is 16, right? So my atomic mass of my first isotope is 16. You get? So my A1 goes to 16, right? Then my A2 is going to be M. You get? A2 is going to be M. They're going to actually calculate for M. You get? Then my percent abundance of my first isotope is 90%. So my P1 is going to be 90%. So P1 equals 90%. Then P2 equals 10%. So what I actually calculate is my M, which my atomic mass unit of this second isotope here. You get? So what you want to do is substitute your value into this formula here and calculate your M. You get? So my MR is 16. 16.2 equals to my A1 is 16 times my P1 is 90, right? Plus my A2 is M, which I'm looking for, M times 10 over Yeah, 90 plus 10, right? So 90 plus 10 is going to give you 100. You get? So it's going to be 16.2 equals to 16 times 90. 16 times 90 what 1440 plus what 10m over what 100. Right? So now when you cross multiply here we have what 1440 plus what 10m plus what 16.2 times 100. Get we have 1440 plus 10m so 620. You get so make use of the formula here we have 10m equals to what 1620 minus 1440. You get so if you subtract it here we have what 180. So now when you do this calculation here my m is going to be what 180 over what 10. Here I have what 18. You get here I have what 18. So that my m is going to be what 18. So the calculation here we have what m equals to what 18. So it means that my mass unit of what my second isotope is going to be what 18. You get 18 what AME. So you can see how easy it is to what to use the formula method to what solve problems. So I'm going to leave some question at the description below, so you are going to attend those questions yourself, right? So in the next video we are going to talk about what how to calculate what percent abundance of each of the isotope, right? Each of what of the what isotope. So make sure you watch those videos, right?